Good day to all of you. Today we shall study attribute closure. Let's start the session. The closure of a set of attributes X, which is denoted by X plus, is the set of all attributes that X can determine using the given functional dependencies. Or closure of an attribute or set of attributes X is the set of all attributes that are functional dependencies on X with respect to F. It is denoted by X plus and it means what all X can determine. The functional dependencies are the relationships between attributes in a database. Next, we shall see to some examples on how to find closure of an attribute or a set of attributes X. Then we can understand what exactly is closure and how to find closure as well. Okay? To find attribute closure, here we'll be finding the closure of one attribute or set of attributes. The steps are: add given attribute set to the result set. Recursively add elements to the result set which can be functionally determined from the elements of the result set. Let's see the first example. In this example, functional dependency A determines B is given. Then we are asked to find the attribute closure of A. The solution is, according to step 1, add given attribute set to the result set. The given attribute set is only A. So that A should be added to result set. That is what is the first step in the solution here. The given attribute set, that is only A, so that is taken, that is added to the result set. According to step 2, recursively add elements to the result set which can be functionally determined from elements of result set. So this is result set. From the elements of result set, which other attributes can be functionally determined, they must be added to result set. So in result set we have A. From A, functionally which other attributes can be determined. So then we have to see to given functional dependency. A determines B. Hence B has to be added to the result set now. To element B is added to the result set. The final answer is the closure of A is equal to the set of attributes A and B. Let us see to another example. In this example, if functional dependency A determines B and B determines C, then find the attribute closure of A. The solution is, according to step 1, the given attribute is added to result set. Because we have to find the attribute closure of A, that is the given attribute or attribute set that is added to result set. A attribute is there in the result set. From the given functional dependency, A determines B, hence B must be added to the result set. Hence in the next step, B is added to the result set. Now in the result set, B is present. By the given functional dependency, B determines C, hence C is added to the result set. The set of attributes A, B and C. We'll see to next example. The given relation R has attributes A, B, C, D, E, F and the functional dependency set is B determines C, BC determines AD, D determines E, CF determines B. Find the attribute closure of B. So in this example, relation R with attributes is specified. The different functional dependencies are given here and we are supposed to find out the closure of B. The solution is, the given attribute is added to the result set. It indicates that any attribute can determine itself first. Next, if you observe functional dependency set here, B determines C. Hence here we have to add C to the result set. Next, if you observe the functional dependency set here, BC determines AD. So in result set we have BC, hence AD must be added to the result set. So AD are added to the result set. Next, if you observe functional dependency set, D determines E. So in the result set we have D, hence E must be added to the result set. So E is added to the result set. So the functional dependency which is not used is CF determines B. So C is here but F is not present. Hence the procedure is stopped here. So closure of B, that is B plus, is the set of attributes B, C, A, D and E. So B can determine itself first and other attributes as per these functional dependencies they are added to the result set. So closure of B is equal to the set of attributes B, C, A, D and E. We'll see to another example. In this example, relation R with A, B, C, D, E, F attributes specified. Then functional dependency set shows E determines A, E determines D, A determines C, A determines D, A determines F and AG determines K. Find the closure of E, that is E plus we have to find out. The solution is E closure has to be found out. So first E can determine E, hence E only is added to the result set. Next, if you observe the functional dependency set, there E determines A, E determines D, hence A and D must be added to the result set. So in the next step, A is added, then D is added. So far, E determined E, then according to functional dependency set, E determines A, E determines D. So A and D are added to the result set. Now in the result set, A is there. In the functional dependency set, A determines C, A determines D. So C and D must be added. D is already added. Hence in next step, C is added, D is already added. Now in the result set, AE is present. Here AE determines F. Hence in next step, F must be added. So F is added to the result set. So this functional dependency cannot be used because AG determines K but G is not present here. So the procedure has to be stopped here. So finally, closure of E, that is E plus, is set of attributes E, A, D, C and F. E plus. Next we shall consider the last example of today's session, that is example 5. In this relation R with attributes A, B, C, D, E is specified and the functional dependency set F is given, in which we have A determines B, B determines C, C determines D and A determines E. We have to find the closure of this functional dependency set F. The solution is, here closure of F is asked. F is a functional dependency set. Then F plus means what all other set of functional dependencies can be found out from these functional dependencies. That is the question here. So we should consider first A determines B functional dependency in the functional dependency set F. So when we consider, so A attribute is taken, it can determine itself, so A is added to the result set. Since A determines B, B is also added to the result set. Since B can determine C, next C is added to the result set. Since C determines D, next D is added to the result set. In the result set, A is present, A can determine E, hence A to the result set. So from this functional dependency we had started, we have found out A closure. Next we'll have to consider B determines C. So next B determines C is taken. So B determines itself first. Next C. C determines D. So D is also added to the result set. We have found out closure of B is the set of attributes B, C and D. Next we'll have to consider C determines D. So next C determines, So first itself, then D is added. Then so from this FD in F, we have got C closure is the set of attributes C and D. Next, in functional dependency set, we have A determines E here. This set of functional dependencies, then F plus is, so A determines A. So A determines A. Similarly, we can write A determines B, A determines C, A determines D, A determines E are written. Next, we'll have to write B determines B. That B determines B, B determines C, B determines D. So after B determines B, B determines C, B determines D. Then from C closure, C determines C, C determines D. So next we have C determines C, C determines D. That completes the solution, and this will be F plus as per the solution. That is closure of functional dependencies set. That is set of all the functional dependencies that can be determined by this functional dependency set F. Here Armstrong's axiom rules are used. Here in finding the closure of an attribute or set of attributes, Armstrong's axioms are used, that is inference rules. There are two sections, primary rules and secondary rules. This I have covered in previous video, that is Armstrong's axiom rules. Please you refer to that. That completes the closure and how to find attribute closure. That is exactly what is meant by closure. The closure of a set of attributes X, which is denoted by X plus, is the set of all attributes that X can determine using the given functional dependencies. Or closure of an attribute or attribute set X is the set of all attributes that are functional dependencies on X with respect to F. This is denoted by X plus, which means what all X can determine. Functional dependencies are the relationships between the attributes in a database. So from closure, we can find the attributes which can determine other attributes, that is first point. Then from one set of functional dependencies, another set of functional dependencies can be derived. These can be used in determining superkeys, candidate keys in a relation. That we shall see in next video session. Stay tuned. I hope you have understood. Thank you.